Hi everyone, this is Mrs. GA, and today we're going to learn how to write and evaluate logarithms. Alright, before we start, I have a quick warm-up for you guys. So please describe the process and steps of finding the inverse of a function, then find the inverse of the function y equals 3x minus 2. Okay, so our quick review is to find the inverse of a function, we first swap x and y in our equation. So we swap the relative positions. So you can see I did that here. And then we simply solve for y. So we add 2 to both sides and then divide both sides by 3. So just be careful here when you're dividing by 3. You do need to divide both terms by 3. So you can write it as 1/3 x plus 2/3 or as x plus 2 all over 3. Either way, both are being divided. And then remember, this is the symbol that we use for an inverse function. Alright, so now we're going to talk about this new concept called a logarithm. So before we actually talk about what it is, I kind of want to talk about why it exists. And we can do that by finding the inverse of the exponential function y equals 2 to the power of x. So let's start that process. So remember, step 1 is to swap x and y. So let's do that. We would get x equals 2 to the power of y. So then our next step is to solve for y. But how do we solve for y if y is in the exponent, right? We have no way of doing that so far. We can't add, subtract, multiply, divide. So we need a new type of operation, and that's where logarithms come into play. So we use logarithms anytime we need to solve for the exponent, like in this case. So we can actually write any exponential equation as a logarithmic equation. So if we have an equation that looks like this, b to the power of x equals a, we can rewrite it as a logarithm like this. So remember, logarithms define exponents. So our exponent, which in this case is x, we'll say x equals, and then we write the word log. That's how we abbreviate a logarithm. Here our base was b. The base of our exponential expression was b, so it becomes the base of our logarithm. All logarithms have a base, and we write it like this down here. And then whatever is left over, this a value, goes right here. And the way we read this is log base b of a. So x equals log base b of a. So you can see that by using this logarithmic expression, we can actually solve for an exponent, which up until now we hadn't been able to do. So a few things about logarithms. Our base, b, whatever this value is, it must be greater than 0, so it must be positive, and it also can never equal 1. So again, it should be positive, but it cannot equal 1. So now that we know how to do this, we can actually finish finding the inverse of our function above. So far we were able to get to x equals to the power of y. So now to solve for y, which is part of finding the inverse, we'll just simply rewrite it as a logarithm. So y equals, remember logarithms define exponents, and then we write the word log. Here our base was 2, so it becomes the base of our logarithm, and then whatever is left over, x, goes right here. So y equals log base 2 of x. And then it turns out this is actually our inverse. So logarithms are actually the inverse to exponential functions. All right, so a few things to remember about exponents before we move on, because we'll need to use these facts for the rest of the lesson. I want to remind you that any number raised to the power of 0 always equals 1. Okay, another thing to remember, negative exponents, they don't make your answer negative, they actually cause reciprocals. So remember, 2 to the power of negative 2 does not equal negative 4. It actually equals 1 over 2 to the power of 2, which is 1/4. So remember, it causes a reciprocal. So notice that it simply goes from 2 to the negative 2 to 1 over 2 squared. And then you can evaluate from there. So remember, negative exponents don't make your answer negative. And then last, we can rewrite any radical expression as an exponential expression using a rational exponent. So if an exponent, that's a fraction. So here, if we have the cube root of 15 squared, we can rewrite that as 15 to the power of 2/3. So remember, inside out, inside out. So just a few quick reminders about some interesting properties of exponents. Alright, so here first we're going to just simply practice rewriting these exponential equations as logarithmic equations. So the number one thing to remember is that logarithms define exponents. So whatever your exponent is what your logarithm is going to equal. Here our exponent is 3, so we say 3 equals log. Our base is 4 in the exponential expression, so it's going to be the base of our logarithm, and then 64. So 3 equals log base 4 of 64. Make sure we read it correctly. For the next one, it defines our exponent. So 5 equals log base 2 of 32. Next one, our exponent is 2. So it's going to be 2 equals log base 7 of 49. And lastly, again, our exponent is 2, so 2 equals log base 1/5 of 1/25. So notice it's okay to have a base that is less than 1, so some fraction, as long as it is still positive. So remember, your base must be positive, but it cannot equal 1. Alright, so I have 3 for you to try on your own. Please pause the video and give these 3 a try, and we will check your answers in just a few moments. Alright, go ahead and check your answers here. The first one, 3 equals log base 3 of 27. Here, 0 equals log base 7 of 1. And here, x equals log base p of k. So remember, logarithms define exponents, and the base of your exponential expression will always be the base of your logarithm. Alright, so now we're going to do the exact opposite. We're going to rewrite these logarithmic equations as exponential equations. So I always like to start with the base. So remember, the base of our logarithm is the base of our exponential expression, so 2. Logarithms define exponents, so here our exponent must be 3. So 2 to the power of 3 equals 8. For the next one, you can see our base is 3. Our exponent is -4, 3 to the power of -4, and that should equal 1/81. And last here, 9 to the power of 0 equals 1. Alright, I have 3 for you to try on your own, so please pause the video and give them a try, and we'll check your answers in just a few seconds. Alright, go ahead and check your answers here. We have 5 squared equals 25, 3 to the power of -2 equals 1/9, and z to the power of x equals y. So next we are going to move on to evaluating logarithms, but before we do that, I do want to talk about a few special logarithms that we're going to be working with. So the first one is called a common log. So a common log is a logarithm that has base 10. Whenever you have a base 10 logarithm like this, we actually don't ever write the base 10. So instead of writing log base 10 of 5, we would just write it as log of 5. So it's really important that you understand when you don't see a base here, it's really a base 10. And this is something that most scientific calculators can do. Almost all of them can do common logs. The next special logarithm is called a natural log. So a natural log is a logarithm with base e. So remember, e is a variable that stands for an irrational number, which is approximately 2.7, and we learned this when we talked about our exponential functions. So again, if we ever have a logarithm with base e, like log base e of 7, we actually write it a little differently. We write it as ln 7, the way we read it is natural log of 7. We don't actually read it as ln7. We say natural log of 7. So whenever you see something like this, again, it's really important that you understand this is simply a logarithm with a base of e. So look out for common logs, which is a logarithm with a base 10, or natural logs, again, a logarithm with base e. Okay, so now we're going to practice evaluating logarithms, which essentially means looking at an expression and saying what is the value of that expression. So here we're going to evaluate the following, and just remember, logarithms define exponents. So if you can remember that, then it will help you when you are evaluating. And sometimes with these, it kind of helps to rewrite it in a type of exponential equation. So here in this first one, we have log base 6 of 36. So this logarithm has a value. So we have to figure out what that value is. So remember, again, logarithms define the exponent. So we're saying if the base were 6 and we're solving for the exponent, it would equal 36. So in your mind, you're thinking, okay, 6 to what power equals 36? Oh, 6 squared. So this logarithm is actually equal to 2. Log base 6 of 36 is equal to 2. So again, we're essentially solving for the exponent if 6 is our base and our result is 36. So let's look at this next one. Here, we're saying, okay, our base is 2. What must our exponent be if our result is 1 over 8? So the first thing we notice is that we go from a non-fraction to a fraction, which means that we must have a negative exponent. Remember, negative exponents create that reciprocal. So we know that it's going to be negative, and that would bring the 2 to the denominator. And then we say 2 to what power is 8? And that would be cubed. So our answer is negative 3. So the negative flips it to the bottom, the 3 turns the 2 into an 8. Okay, let's look at this next one. Log base 12 of 1. So we're asking ourselves, okay, what must the exponent be if the base is 12 and the result is 1? Well, we know that any number to the power of 0 equals 1. So anytime our result is 1, we know that that logarithm is going to be equal to 0, because that's the only way to take a number, raise it to a power, and get 1. Okay, in this next one, this last example here, we have a common log of 10. So remember, this is one of our special logarithms. We don't see a base, but it's implied that the base is 10. So we're essentially saying 10 to what power equals 10? We know 10 to the power of 1 equals 10. So here you'll start to notice a pattern. Whenever the base and the result are the same, base 10, this is 10, the logarithm must be equal to 1. So again, as long as you can remember that logarithms define exponents, you should be able to set up some type of little equation to help you evaluate. Alright, so at this time I'm going to ask you to pause the video and give these 3 a try, and then we'll check your answers in just a few seconds. Okay, go ahead and check. So first one, you're saying 3 to what power equals 27? So this logarithm is equal to 3. Here we have a common log. So remember, 10 to what power equals 1 over 10. So remember, anytime you're going from, you have that reciprocal action, you know your exponent is going to be negative. So here we have negative 1. Then 4 to what power is 64? So it must be 3. Alright, so here we have a couple of challenge problems for you. So here we have a logarithmic function, f of x equals log base 4 of x. So all of these are going to be base 4. And I'm going to ask you to evaluate the following. So we'll do one together. Here, when they say what is f of 256, that means we're replacing x with 256. So we're evaluating log base 4 of 256. So again, you're asking yourself 4 to what power equals 256? And that's actually 4 to the power of 4. So 4 to the power of 4 is 256. So these 3 are a little bit trickier, so again, please pause the video and give them a try on your own. Again, they are challenge problems, so give it your best shot, and we'll check your answers in just a few moments. All right, let's check our work here. So here log base 4 of cube root of 16. So 4 to what power is cube root of 16? So we know that 4 squared gives us 16, so we have the 2. But remember, if we want to create that cube root, then we have a rational exponent, or an exponent that's a fraction. So that 3 creates the cube root. So the 2 on top squares to get 16, the 3 on the bottom creates the cube root. On the next one, log base 4 of 2, so 4 to what power equals 2. So remember, if you notice, say, oh, the square root of 4 is 2. We can actually create a square root by using a rational exponent. Remember, if you want a square root, it's just raising something to the power of 1/2. So again, 4 to the power of 1/2 means square root of 4. So anytime that you see a reduction in values like this, you can guess, oh, I'm going to have a rational exponent. Hopefully, it'll be some type of easy root. Now, this last one is the trickiest here, so it's okay if you weren't able to figure this one out. So essentially, 4 to what power equals 8? So you have to think, well, I know that if I do 4 cubed, that gives you 64. And then the square root of 64 equals 8. So if I want to do the square root, I'd have to do the 1/2. So it becomes 4 to the power of 3/2 equals 8. So again, I cube it to get 64, and then I square root it to get 8. So this is definitely a tricky one. Okay, so that is all for today's lesson. Thank you so much for watching.